So, hi everyone, I'm Lilit and this is Laila. And my project is Autonomous Lake Surface Cleaning Robot. My supervisors are Lilit Asatryan and Vagan Mkhitaryan. So, let's start with the outline of today's project. Sorry. So, first, we're going to talk why we even decided to make this project. What problem is it going to solve? Then, how we designed it, how we made it, how we manufactured it, and finally, the testing process and some future improvements as well. So first, let's understand why are we concerned about the fact that there is a problem with lake pollution. Firstly, it harms the pollution harms the ecosystem because it lowers the oxygen levels in the lake, which is bad for natural habitats and biodiversity. Also, just logically, we can say that it is not aesthetic to be around a lake that smells and is polluted. Also, it is bad for the infrastructures because it is damaging the whole. The pollutant is damaging the debris, the structures there. And of course, there is solution, the manual removing method, but it is first time consuming and it is very labor intensive. And also it is not scalable and effective for different types of water bodies. So that's why we decided to make this robot, which is going to collect all the debris from the lake, and it is somehow highlighting the technology's role in sustainable water management. My inspiration came from the Microsoft ClearBot, which is basically the more advanced one. It is powered by AI and it is again collecting the debris and waste from the lake surface. But in my case, first we made it cost affordable, and also it is kind of made in a way that it is easy to transport because we can assemble and disassemble it easily. And firstly, I have the mechanical system, the things you can see here, the hardware which is in this box, and the software which is kind of controlling all the operations happening here. These are my initial designs. As you can see, my main point and purpose was to have something that has a place in the center. And the conveyor initially was planned to be just rollers that are moving the object on it. But then, as you can see, here is my final design. And now we're going to talk more about it. So first, as you can see, we decided to take the catamaran style. Why that? Because first of all, as I've already said, there should be a place for the conveyor for it to, because it's going to be partly in the water to take the debris from it. So that's why we need that space for housing it. And also, we didn't really need a high speed for this type of robot because it's going to kind of move slowly in a medium speed. In order not to disturb the collecting fact. And also there is little drag by using the catamaran. First, the hulls, the two sides of the catamaran, they are, this is the SolidWorks model, and we used laser cutting and CNC milling for these parts. The dimensions are 1.5 meters to 6465 centimeters. And the materials that were used were Panoplex and plywood. And as you understand, because of the Panoplex and plywood, it is a composite material, and we used the sandwich method. Why? Because we needed something that would be strong enough to carry all the weight. So that's why we made the skeleton from plywood, and we attached 2 layers of Panoplex to the both sides. And this is called the composite materials, and we use Panoplex because it is light in the weight, and plywood plywood is strong enough for a structure. Also, it was kind of efficient manufacturing because we just used laser cutting and CNC. We used laser cutting for the whole both Panoplex and plywood, and CNC for having their own edges because we wanted it to be perfect. It was in the SolidWorks. Also, Panoplex is water resistant, plywood isn't, but after some manufacturing, we made it water resistant. And lastly, we had and still have the budget problem. That's why we wanted something that is cost effective and kind of easily, we can find it easily and buy it easily. Then the structural boxes, we need a structure to hold the hulls together and for it to be strong. That's why again we use plywood, and for making them we used laser cutting manufacturing again. The front one here is just for the structure, it doesn't really have any other purpose, but the upper one and the lower one here, the upper one is for electronics. We are keeping everything here, and as you can see there is a rubber layer under the lid. It's for extra waterproofness, even though it's not going to be, the water level is not going to be this high, but just in case because it's all electronics. And the lower one is for housing all the wires and keeping it organized. Then the conveyor system, honestly, it is the most complicated part of this project. Here you can see how the conveyor belt links were made. We used PLA, we used 3D printing with filament PLA to make the links, and they are connecting together with the 16mm rods and 2 leads to kind of keep it attached, and there are 16 almost identical links together, and this is how the belt is moving. Yeah. Then the gear system. The gears are made from the carbon PLA, which is basically PLA filament with extra carbon particles in it, and it's again 3D printed. But as you can see, one of them kind of differs from the other 3. It's because we needed it to be attached to the motor, and we needed it to be strong enough so that the motor and the gears can move the conveyor and its weight. I'm going to talk about later, but there is a 5:1 reduction ratio to the step motor. And the side supports, actually we needed a place for the conveyor to be housed in the house and somehow to be connected to them. That's why again we used plywood. We did the laser cutting again, but here in the holes of the sides are 3. In each hole there is 1 ball bearing for the conveyor to rotate smoothly and kind of easily, and not to have all the force only just on the stepper motor. And now the electronics. First, the battery. We used 5S 8P battery for hold the electronics. It's going to move the propellers and the stepper motor as well. Then the stepper motor driver and stepper motor itself. First, why we decided to take this driver, especially because we needed something that is compatible both with the stepper and with the pickstock, which is our brain of the system. Also, it is small in size, which is important for us, so it can be in the box as well. And we just need driver for rotating the motor and controlling its power. And why especially this gear? First of all, I already say there is a budget problem, so we needed something that is affordable, but also the 15:1 reduction ratio is really good because it is not small enough for it to rotate in its place, but not big enough for the conveyor to move very slowly. So yeah. Then there is the thruster and ESCs for the thruster. Actually, the ESC and the thruster came with a kit, which is a good deal for us because, and also there was a extra propellers in them. And we decided to take this one because, first of all, it has enough thrust for us, but also it was good manufactured because the propellers were already inside of it, and it was kind of user-friendly, you know. And the ESCs came with it, and they're just for rotating the changing the rotation direction of the thruster. Then pickstock is the brain of our robot. It's controlling everything here, the motors, the driver of the motor, of course, and then the motors, the thruster, and this driver as well. And we connect it to the computer and use mission planning for it to move autonomously. And also there in a kit with Pixel, they came some extra things such as a GPS module and telemetry module and we definitely used it. Then the bill of materials. I actually put this here for you to understand that we went over the budget that were given to us. That's why I mentioned multiple times that there was a budget problem and that we tried to find something that is cost effective. And now the manufacturing process, the fun part here. Here's the laser cutting of the hulls and the CNC milling. As I already said, we needed something precise, so that's why we especially use CNC for the front part of the hulls, the round parts. Then we used an extra super special glue for connecting the Penaplex and the plywood together, as you can see, and then we put it under the press for it to absorb the glue completely. And this is the final view of the floating platform before it was manufactured further. Now the conveyor, as I've already said, every and each part of the conveyor belt is 3D printing, and here is one of the links of the conveyor being printed, and this is the connecting small parts, the white parts here. And this is how the electrical box here looks like. Yeah, and then the painting process, we just spray painted the conveyor belt links because we didn't have any waterproofing problem. But for the floating platform, we actually used the rubber paint because we needed it to be waterproof, and rubber paint actually is the paint that is used in the swimming pools to make them extra waterproof. And then we just sprayed it red and assembled together. Oops. Then the testing part. Went to the testing. And here only the propulsion system is working. Conveyor right now isn't working. We did this to understand if it's like moving correctly right to left and back as well. And here is how the conveyor system is working and grabbing the black cup there. And also then it is like moving forward, so they're like working simultaneously. And of course we have some future things to do. The first one is we want to make an autonomous docking system. Imagine having the robot that works the same way that the vacuum machines in our home, just for the lakes. And also we want to have some environmental monitoring when it is in the dock and it's recharging. We want to have some sensors such as pH levels, sensors for pH levels and temperature to just collect some data. And also we want to have an AI tool for debris detection, so it would detect the debris and plan its mission accordingly to be efficient enough. And during the testing, we understand that there are some problems with this conveyor part because it wasn't long enough to grab completely the waste. So that's why I think we need to kind of enlarge it as well, make it longer. And I want to say thank you to my supervisor because they did a great job and really helped me. But also I want to say thank you to Mr. Lilit Asatryan for helping me and providing all the things I needed. And I also want to say thank you to Mr. Levan factory workers who kind of helped us with their expertise. But last but not least, the fellow engineering students from AUA who helped and guided me and make the process really enjoyable. I think this process wouldn't be this good without their help. So yeah, thank you very much.
Why did you use a stepper motor?
Because first it was cost affordable, and yeah, it was cost affordable, yeah. But like the fact that it is counting the steps isn't really necessary for us. We just choose it because it was not really that costly for us. Because servo motors are high in the cost. The ones that can move the conveyor are costly.
They're costly.
Yeah.
Okay.
Have you considered that when you collect the garbage, it changes the center of gravity of your boat? Like it's collecting all the way back in your collector, in the container, right?
Yeah.
So it changes your center of mass to the back.
Yeah, it
I
is.
believe it should affect. There are a lot of garbage collectors that have this kind of hands of to collect more garbage? Is it something that you would have considered?
Yeah, honestly, at the beginning we decided not to make this type of like the rotating conveyor, but the thing that have like little arms that is opening and closing to like have the more trajectory for collecting the debris. But actually there were some problems like the opening and closing part, and also some garbage being stacked on the edges or like in the parts of that type of conveyor. So that's why we didn't really do that. Also about the center of gravity, actually, we do really think about it, but the fact that it's collecting debris only from the surface, which basically means that the pollutants on the surface are light enough to be there. So collecting them, and you can see the basket isn't really that big because right now it doesn't have a system to autonomously reload itself. So that's why I think the waste it's gonna the waste is gonna collect right now, the debris isn't really big for it to change the center of gravity.
And also for the propulsion, the same comment for you. Don't consider these propellant types of the thrusters. Use jets.
Why?
Because if you're talking about the garbage, then it's an issue for your propellants to get stuck with different kind of garbage there. So if you use a jet, it works more simple. It takes the water and uses the jet as a propulsion, and it's also throttleable. And you can use a single one, not two. But yeah, I understand what you use two.
It's
you can
like,
still
yeah.
use two if you want, but that's more efficient as a thruster for boats like this.
Okay, I'll take the advice, I guess.
And the budget should be increased.
Yes, please.
Out of curiosity, what is the speed of your conveyor?
Like right now,
Yeah.
uh,
How quickly it removes?
it isn't
Why?
really.
Why I'm asking, because it creates a back thrust,
Mhm,
yeah? And your thruster should always be working, consuming electricity to counter the thrust
Compensate.
when it is working.
Mhm.
Also, it was quite a good observation from your side for the future group to make the baskets a bit wider, because you are losing a lot of garbage on the sides.
Mhm.
And Hike's observation that you could have big arms to catch more area to make the system more efficient, because at present you're working with is the weight of your vessel, whereas if you could have a bigger catchment area, that would make it more efficient. Also, have you considered having a balance to counteract the tilt when you collect the garbage? Because as you collect the garbage, your vessel will tilt, your nose will go up. You have to keep it.
Yeah.
Actually, the basket is quite in the center, so that accounts for part of the weight. But also, as we have thrusters in the back, so that kind of increases the efficiency when you push them a little bit to back. And the conveyor belt by itself
thrusters themselves, not the efficiency of the garbage.
yeah, but the conveyor belt by itself is quite heavy, so we already a bit forward centric. Yeah. And regarding the garbage collection part, I think the model is quite scalable.
Yeah.
So as we used kind of everything that we did can be scaled to a larger model. So that's one of the solutions you can provide for bigger objects.
Our concerns are transportability in this stage, because when you want to do testings every week, it's awesome to.
Well, we saw that's a quite modular design. You could have easily detach the modules.
And for the container of the garbage, actually, they didn't mention that, but we have the garbage actually floating during the transportation also, because the container has holes underneath. So some part of it is catched and it is still floating with the boat. So it's actually not adding too much weight on the boat itself. So it's floating
The
with
same
the
question, are you planning to continue this?
I mean, if I have a chance to continue, yeah.
If you got it.
Yeah.
And one question, what if we remove all of this part which is inside?
Mhm.
That and just collect it from the surface and have a net behind, and it will be much easier. I mean, it will not be so heavy, and will be no like resistance in the movement of this chain.
So you're just
just
saying.
collect it and come to the shore.
So you're just saying to have just only the house and the net connecting to it, right? Did I
Yeah,
get it
and
right?
remove all of this in the middle. All of
So
this
like
metal.
not the electronic box, not the conveyor,
No, not the conveyor.
only
the,
not the conveyor.
the method of
Not
garbage
conveyor.
collection.
If it's, as you said, it is from the surface, then we can just go and with the arms just collect it and come to the shore.
But how can we be sure that while collecting the debris and while moving, it wouldn't go out of the net again? Do we have to like collect it again? Me too. That's why I didn't do that.
Very good.
Good job.
Thank you.